Law of Sines. This video tutorial is embedded in our webpage mathwarehouse.com/law of sines, where you'll find other goodies on the law of sines, including a 25-question worksheet with an answer key, an interactive demonstration, and some other practice problems. Okay, the goal of this tutorial is to understand how to apply the law of sines and when to use it. You can see the formula for the law of sines on the screen here, and the law of sines basically relates any one of a three triangle sides, whether it's side A, B, or C, and that side's opposite angle, actually the sine of that angle to be specific, the sine of an angle over its opposite side to the sine of any of the other angles and that angle's opposite side. And it basically is saying that the sine of an angle over its opposite side is always proportional to any of the other sides' sines and sides. Sine A over its opposite side A is equal to sine B over its opposite side B, and the same for sine C and C. Since these are proportions, you can always cross multiply and rearrange them so that the formula looks like the bottom here. So you can either put the side length or the sine of A on the top. It doesn't matter. You can use the top or the bottom, whatever's more convenient for solving the problem you're trying to do. So let's actually try to do a law of sines problem. Let's try to first work on solving problems using this formula, and then we'll end the tutorial by looking at when you should actually use the law of sines. Okay, this is question 7 from the worksheet on our webpage. You have triangle ABC, and we want to find B right here to the nearest hundredth. So just remember, we can put sides or sines on the top. So we can approach this problem by saying B over sine B equals A over sine A, or we could also use C over sine C, whichever ones we want. Or we could even put the sines on the top, right? Like if we wanted, we could say sine B over B equals sine A over A equals sine C over C. Any of these are going to work. Our first job is to figure out what sides and angles we want to use. The key to this first step of the problem, when we're just trying to figure out what measurements to use, is to realize that we're always talking about opposite sides and angles. We need a pair of opposite measurements. So let's look at what we have. We have a 53-degree angle, but we do not know its opposite side. So that does not look like that's going to be helpful for this problem. We have an 8-degree angle and its opposite side. Alright, so this looks like it might be useful. You're always looking for opposite measurements in the law of sines. And what are we looking for? We're looking for B, and we have the angle opposite B. So here are the sides we want. First step will always be to try to identify a pair of known opposite measurements, in this case 8 and 27. And then if we're looking for B, we need to try to find the measurement opposite that, which we have already. Alright, so we can now just basically plug these into our equation. Since we're solving for B, it's going to be a little easier to use the top form of the equation rather than the bottom. And you'll see why at the end of this. Let's just do it, and I'll explain why at the bottom if it's not obvious already. So B over sine of 19 equals, if we put a side on the top, we're going to need to put 27 on the top over here, the side length, over the sine of 8. Now it's very easy to find B. We just cross multiply, right? B equals sine of 19 times 27 over sine of 8. If you had put B on the bottom and sine of 19 on the top, you'd get the same answer, and it would be fine. It would just be a little more work. So a nice little trick to doing these problems and saving yourself some time is always use the form of the formula that puts what you're solving for on the top. If we're looking for a side length, use the top. Use the top form. Use the one where the side length is on the top of the proportion. Alright, so at this point, get your calculator out and let's punch these Alright, the length of B rounded to the nearest hundredth is 63.16. Alright, so we're done this problem. So just to reiterate, how you approach these is you look for a pair of known measurements that are opposite of each other. In this case, that's why we use the 8 degrees, because we went with the 27-degree measurement opposite of it. Since we did know 153 degrees here, but its opposite side was unknown, so it doesn't help us in this formula that is all about angles and their opposite sides. You're trying to find B, so you need to know its opposite measurement. After that, it's just choosing which form of the formula you like, the top version or the bottom. Again, if you're trying to find a side length, put the side length on the top of the proportion, which is this form of the formula. From there, it's just punching it into your calculator and rounding. Okay, so let's try another problem from the worksheet, problem 8. We have triangle DEF. We're trying to find the measure of f to the nearest whole degree. It's a little bit different. Here we're trying to find an angle, unlike the last problem where we found a side length. So remember, the first thing you're doing is trying to find a pair of opposite measurements. You want an angle and a side opposite of each other. And if you look at this, you'll see right off the bat, hopefully, that here is what we want. We want the 50 degrees because it's opposite of a known measurement. We have a pair of opposite measurements. What are we trying to find? We're trying to find f, right? The measure of f. Therefore, the other pair of opposite sides and angles that we want is f and 8. The 15.5 length here is not helping us because we do not know and we have no way of figuring out angle E. Well, no way of easily figuring it out. So we can ignore that. Alright, so now we're going to set it up. Remember, it's a little easier to put the variable you're trying to find on the top. So if we're trying to find an angle, we should put the sine of that angle on top and 8 on the bottom is opposite the sine of 50 over 12. And just to reiterate, you could do this problem just as accurately this way. It would just take an extra, like 20 seconds of work or so. Either one of these will get you to the final correct answer, but always put the variable you're trying to find on top to make your life a little easier. Alright, so the next step is just to cross multiply 8 sine of 50 over 12. And here we need to get our calculator out. And the sine of f is 0.51069. We're not done yet, and actually I just want to take a moment to point out many students incorrectly stop these kind of problems here. When you're trying to find the measure of an angle, you can't stop at sine of f. You actually have to do one more step because it didn't say what is the sine of f. The question asked for the actual measure of f. So if you remember, now we can use the inverse sine to get the actual measure of f, which, if you're rounding to the nearest whole degree, is 31 degrees. Alright, so just a quick recap. To do these problems, you look for opposite measurements. We need at least one pair of known opposite measurements. In this case, it was the 50-degree angle and the 12 side. Right, use that here. Identify the other pair, which is what you're trying to find, angle F, and the 8. 15.5 was of no use to us because we didn't know its opposite angle. This is all about opposite measurements. From there, it's just using your calculator and remembering that you do not stop at sine of f. If it asks for f, you have to take the inverse of the sine to get 31 degrees in this case. Okay, let's try this one is a slightly trickier problem. Students often have to do this when they first learn the law of sines. We want to again find in this case we're trying to find side length E. And let's just try to start it and see how we can get to that. Alright, your first job is to identify a known pair of opposite measurements. We have a 54 degrees opposite of 7, looking good. Now here at first, it may look like this problem can't be solved using the law of sines, because 59 degrees is opposite an unknown side. Okay, look, can't use that. E that we want is opposite an unknown angle. It looks like we can't use that either. However, all you have to do is remember one thing, that the total degrees of a triangle's interior angles add up to 180. So angle E is just 180 degrees minus 54 minus 59 degrees, which is 67 degrees. So just remember, when this problem will probably surface in your class if you're learning this. If you're given two angles, you can just remember you can always use an old formula, the sum of the interior angles formula, to get the third angle. Once we have this third angle, we can use the law of sines. We're trying to find a side length, so put the side lengths on the top of the formula. E over the sine of 67 equals 7 over the sine of 54. You know the drill, cross multiply, and use your calculator. And if we're going to round our answer to the nearest hundredth, the answer is 7.96. Okay, there's only one additional step in this kind of problem. If you're given two angles, just remember you can always get the third angle so that you have not only a pair of known opposite measurements, in this case the 54 and 7, but you can also get the angle opposite the side you're trying to find. Okay, let's end this video tutorial by looking at 4 triangles and trying to just see whether or not we could use the law of sines to find the variable. In each case, we're trying to find the measure of x. It's a side or an angle in these 4 triangles. In some of these triangles, we can use the law of sines to get x. In some of these, we cannot. So let's focus a little on when you can use the law of sines. Let's try triangle number 1. Step 1, identify the opposite measurement pair that you know or can know. In this case, 29 and 11. And we are able to get the measure of the angle opposite x. So this is completely doable. You can set up the equation. You can say x over sine of 118 equals 11 over sine of 29, and if you cross multiply, you can finish that up. So this is indeed doable with the law of sines. Let's now go down to triangle number 3. Okay, well, x that we're trying to find, in this case an angle, is opposite 19. Looks very promising. However, we know one angle and we do not know its opposite side. We know one side and we do not know its opposite angle. So the problem here is that there is not any pair of opposite measurements that we know. And we cannot figure them out. This isn't like the problem where they gave us 2 angles and we could get the third angle. This cannot be done using the law of sines. There are other trickier ways to do this, but not purely with the law of sines. Okay, now let's look at triangle number 2 here. Again, let's try to find a pair of opposite measurements that we know. We have that with this pair. And we're trying to find x, and we know its opposite side. So not a problem. This can be done. You can say the sine of x over 16 equals the sine of 115 over 49. And we've done problems like this before where you cross multiply to get sine of x and then take the inverse of sine to get the actual angle measurement. So just like triangle 1, triangle 2 can indeed be done using the law of sines. Now let's do one more, triangle 4. Alright, we're trying to find x. We know the angle opposite of it. We also know side 11. We do not know its opposite angle. We know we know the angle on the bottom left here is 29 degrees, but we don't know its opposite side. This, though, can indeed work. If you remember, if we know two angles of a triangle, we can always get the third one. The third angle, of course, is going to be 180 degrees minus 29 minus 118, which will give you 33 degrees. So we can figure out that this is a 33-degree angle. And then we've got a pair of opposite known measurements, and we know the measurement opposite what we're trying to find. Yes, this is like that problem we did towards the end where you have to do an extra step. But we could do it. You can set this up saying x over the sine of 118 equals 11 over the sine of 33. Alright, so just to recap one last time, to do these kind of problems, you need to be able to get one pair of opposite angle and sides. Either that will be given to you straight off the bat in problems like triangle 1 and 2, or you have to be able to get to it, like in triangle 4, where you are given two angles and you can figure out the third angle. And you also need to know the measurement opposite what you're trying to find. So if you're trying to find a side like triangle 1, you need to be able to know, you need to know its opposite angle. If you're trying to find an angle like triangle 2, you must know its opposite side. Okay, if you'd like more practice on the law of sines, feel free to check out our webpage, mathwarehouse.com/law of sines, and enjoy the goodies there.